As the urgency for zero-waste building materials increases, Myco-materials, a sustainable composite made by entangling mushroom mycelium around lignocellulosic fibers, have received greater attention from researchers worldwide because they are renewable, biodegradable, and potentially critical to lessen the impact of the construction industry on climate change. While Myco-materials are relatively weak, they have a high strength-to-weight ratio, which suggests that through advantageous material placement, large-scale structures are possible. Recent pavilions and prototype structures have demonstrated this through assemblies of bricks or blocks, structures made with 3D printed components, and large monolithic fabric-formed castings. This workshop lays groundwork for an integrative design-to-fabrication workflow that seeks to expand upon the existing constructive paradigms of fungi-based materials through computational structural design, robotic fabrication, and mixed reality fabrication. Preliminary experiments have revealed that strategic reinforcement strategies with natural fibers and textiles results in performative benefits that could drastically expand the range of possible real-world applications. Based on these findings, our workshop invited participants to conduct an at-home experiment to design and grow a small-scale, fiber-reinforced mycelium composite slab structure and test it to failure. During the workshop, technical talks and software tutorials were given by the team of co-organizers, covering the essential skills participants would need for conducting the at-home experiments. A custom workflow in Grasshopper was introduced that generates fiber-reinforcing patterns for a mycelium slab structure to be tested in the experiment, based on a highly flexible set of design parameters. As a speculation on how robotic fabrication might be used to deploy the custom design reinforcing patterns, the workshop introduced KUKA PRC. Participants learned to simulate robotic movements determined by the reinforcing patterns. Where available, participants received a kit that included materials needed to grow a reinforced mycelium slab specimen and later test it to failure. The organizers demonstrated a tactical approach for participants to physically make their reinforced patterns by sewing them by hand into a grow mold, guided by the free smartphone app, Fologram. The molds were later packed with inoculated hemp fibers, letting the reinforcing to become integrated into the mycelium composite matrix. Due to the time it takes to procure and grow Myco-materials at the time of the conference, the participants are now beginning to grow their reinforced slabs. We'll be happy to return next year to report the results of their load tests and share our continued work on enhancing fungi-based materials. We would like to thank the organizers and the board of ACADIA for their support of our workshop. Thanks again to Karamba 3D and the Association for Robots and Architecture for sponsoring participant access to their software, and thanks to Open Myco for sponsoring the Myco-materials. Finally, we would like to thank our participants all over the world for their enthusiasm for Myco-materials and their energetic engagement in the workshop.